Hi guys, welcome to my YouTube channel. Today I am going to discuss about the problem prime Fibonacci, which was asked in mock beta. The problem statements describe that there are given two numbers n1 and n2. First of all, we have to find out all the prime numbers between n1 and n2. After finding all the prime numbers between the two numbers, then we will make all unique combinations of that prime number, which is made in step 1. After making all the unique combination, we will search or find out that combination is prime or not. If the combination is prime, then what will you do? We will store the prime number in another array or a list. Then finding the prime number from all the combination, we will sort, means find a smallest element in the list or the largest element of the list. We will consider a smallest element as the first element and largest element as the second element of a Fibonacci series, and we will generate the Fibonacci series. Then there is one question maybe arise in your mind: how many terms I have to find Fibonacci series? The number of terms of the Fibonacci series will be depends on the size of array list, which is generated by all the combinations for making the prime number. I will tell you in simple words. Given two number n1 and n2, number can vary from 2 to 100 and their difference must be greater than or equal to 35. There are two test cases given. First, for n1 is equal to n2 and n2 is equal to 14, and there are some explanation. I will try to explain all these things. First, we find out all the prime numbers between 2 and 40. Then we will get this much of the prime number and we store that prime number in a list. After finding the prime number, we are going to make all possible combinations that must be unique from the list. How will you make all the combination? 2 means 2. We will add all the elements. With 2 means we will combine all the elements with 2 one by one. First 2, and we will combine 2 and 3, then we will get 23. Then after we will combine 2 and 5, we will get 25. Then we will combine 2 and 7, 27. 2 and 11, 2 double 11. Then we will combine 2 and 13, 213. Like that we will combine up to 237. Then again what will you do? We will take 3 and we will start combining 3 to 2, 3 to 5, 3 to 7, 3 to 11. But we will not combine the number with itself. After making all again, then we will go to 5 and start combining 5 to 2, then 5 to 3, but we are not combining the number with itself. Then 5 to 7, then 5 to 11, 5 to 13. Like this way we will make all the possible combinations of all the prime number. Then we will store all the combination in a list and array wherever you want. I will explain in programming, but then we have to find out all the prime numbers, from the combinations. Then after finding all the prime numbers from this much combination, we will store it in array or a list. After storing it, we will find out the smallest element in the list and the largest element in the list and the length of the list. The smallest element in the list will be first number and the largest element of the list will be second number, and the length of the list will find out. Then we will consider the smallest element as first number of a Fibonacci series and largest number as the second number of the Fibonacci series. And we will have to find out nth term, means the size of the second list term. If the size of the second list term is 12, then we have to generate 12th series Fibonacci series and we have to print that as output. Same in a test case 2, 13 and 70, we will find out the first prime number between the number, then we will all generate combinations. After generating combination, we will find out a smallest element and largest element. We will make it the first and second number of the Fibonacci series. Then we will find out the size of the second list generated. Size is 14. That's why we will show as the output 14th Fibonacci number in the series. Then we will find 14th number of the series is 2027041 and we will print it as an output. Let's go on a coding part. First we have a declared main function. After taking input n1 and n2, actually we don't know the size. That's why we are declaring the dynamically allocating a dynamically array, because its size is not fixed. We don't know how many prime number will be formed between 2 and 40. That's why we'll run a loop from n1 to n2 and initialize the count to 0, and we'll run another loop I to sqrt of I. Means first we run loop 2 to 14, then we'll run a loop from 1 to sqrt of 1. We can use math.sqrt also, but it will decrease some complexity, that's why. Or we can use from 1 to I also, from for I j equal to 1 to j less than equal to I j plus plus, and we will check if the number is prime or not. Prime number means it will be divisible. It will not be divisible by more than one of a number. Means if 5 is a prime number, then it will be divisible by only 1 and itself, not a number between it. Then we'll find all the prime number, and if a count equal to 1 and increment the count, but it's initially for 2, we'll run a loop sqrt of 2 means 1.41, means per one time it will be run. So 2 modulus 1 equal to 0, increase the count by 1 and our count will be 1. Then we will add in a array list. Same for all the number we will do and add in the array list. After adding all the element in the array list, what will we do? We have to perform all the combination. For combination, we will run a loop from I0 to size of the length and J0 to size of the length. And I told you in the question that we will not combine the same element with itself. That's why if I not equal to j, then only we will use to combine. But the problem arises is suppose we have to combine 2 and 3. Are in the integer form, then what will we do? We will convert 2 to a string form and 3 to a string form and store it in a string form. Then result will be 23. 2 a string is used to concat. After concat, we will convert the string into integer and add to the array list. Then we will get second list of array, which is a prime, which is a unique prime combination. Then what we have to do? Then after finding all the possible prime number from unique combination, we have to sort it, finding a smallest and largest element of the second prime array list. Then we have to find all we have run a loop from I0 to size of the array, initialize the count to 0, we'll get the first element and we will again check the number is prime or not. Means here we have finded all the possible combinations and added to the array list. Then again we will do the same operations for this and find the number is a prime or not, like we have did here. For I2 size we will initialize count1 is equal to 0, then we will get the first element of the list. And for sqrt, first element of the list is suppose 23 out, and we will check 23 modulus sqrt of 23, I k less than 1 equal to 1 and 2 less than 1, 23, and we'll check here. Suppose out equal to 23, and we'll check sqrt of 23. We know sqrt of 23 will be 4, less means 4 point something, which will be, but we will take integer value, that's why it's 4, and we'll run a loop from 1 to 4 and check will it is divisible or not. If it is divisible by only 1, and the count will be increased one time, and we'll check it. If it follows, then we'll add it into the array list. We have declared another array list AR2. Then we will sort the array list. After sorting the array list, we will find the first element of the array list, and we will find largest element, means last element after sorting, AR2 dot size minus 1, and we will take long data type because it may go out of range for integer type. Then we have taken the size of the list. Here we have converted all the array list element to the hash set and counted all the sides. It's not necessary, we can do find array list size also. Then after knowing the size of the array list of 2 second element, what we will do, we will set the first element, we know second element, then the third element will be pivot of 1 plus pivot of 2, then we will run a loop from 3 to less than equal to 5. Means if there is 14, then we have to print 14th element. First element is this, second this, third is here, fifth 3, and after this 3 2 we will run less than 14 is 13, then loop will terminate and will print the 14th element. You can try and run all the code. Let's save and compile the code. It's this logic is simply for Fibonacci series. Getting the Fibonacci series means first term A, second term B, third term C. How will you get next Fibonacci series? This code is generating next Fibonacci series. This almost this is the code. It's taking time, I don't know why. Just a minute. Yeah, compile again. Let's see. Yeah, it's compiled. Presentation error is not a issue. It happens, it occurs due to white space. Let's submit. Yeah, all the cases successfully passed. So thanks.